All right, class. Happy snow day. This is our first attempt at an e-learning day, so we're going to see how it goes. If you've got any feedback from me at home, I'd greatly appreciate it. This is actually the same exact lesson that we would do if you were in class. We are going to do standard 8215, and we're going to talk about geometric sequences. So the first thing I want to do is I want to review what is a sequence. In simple terms, a sequence is a number pattern. So any pattern of numbers could be considered a sequence. We looked at one type of sequence already this year where we took a number and we simply added or subtracted repeatedly to it to form a sequence. This sequence I am forming right now would be considered an arithmetic sequence. We would have 2 and then 4 and then 6 and then 8. And we can see that adding 2 to each of these numbers would continue this pattern. So this is just one example of a sequence. A term of a sequence is one piece of the puzzle. So if we look at this whole expression, this would be considered a sequence, and one item or one value in the sequence would be considered a term. So when we look at the value 8, in this particular case, 8 would actually be considered the fourth term, 6 would be considered the third term, 4 would be considered the second term, and 2 would be considered the first term. So to review, one of our previous standards talked about an arithmetic sequence. Again, an arithmetic sequence is any number sequence formed by adding or technically subtracting a fixed number to each previous value. So I'm going to give you an example of an arithmetic sequence and talk about how it connects to this equation. So this is your equation for an arithmetic sequence. I'm going to start with the number 10. I'm going to actually be subtracting 5 each time here to create this sequence. So because we are adding or subtracting, this sequence is considered arithmetic. We can see that each time we are subtracting 5 or adding negative 5 to obtain this number pattern. This value right here, negative 5, is referred to as the common difference, and it can be plugged into this equation for M. B is considered the zero term, and the zero term of a sequence is the term that would come before the first term. So in this sequence, the zero term is going to end up being 15. So if I wanted to express this sequence as an equation, the equation is going to be y equals negative 5 because that's my common difference, x plus 15. So just to color code here a little bit, again, this value, negative 5, goes in there for M, and your zero term, 15, over here, goes right in there for B. This is an example of an arithmetic sequence, and here is your equation. Okay, so now we're getting to the nuts and bolts of this new lesson that you're going to be looking at today at home in the snow. And this is considered a geometric sequence. It has nothing to do with geometry. But a geometric sequence, running out of room here, is a number sequence formed by multiplying or dividing a term in a sequence to find the next term. So just to give you a quick example, I'm going to use something that's fairly simple. I'm going to use the number 5 to start. I'm going to multiply by 3 each time. So if I take 5 and I multiply by 3, I end up with 15. If I multiply by 3 again, I end up with 45. And this pattern could continue. Because I am multiplying by 3 each time, this would be considered a geometric sequence. Another example would be starting with the number 100. This time I'm going to divide by 5. Now, it does not work in our formula to use dividing. So dividing does not work. We have to eliminate the division sign. But we have to understand that multiplying by 1/5 is the same. So if I multiply 100 by 1/5, I end up with 20. If I multiply that by 1/5, I end up with 4. If I multiply that by 1/5, I end up with 4/5. So this would be another example of a sequence that appears to be dividing by 5, but dividing by 5 is the same as multiplying by 1/5. A common ratio is this value that we are multiplying by each time. Again, a common ratio has to be multiplication. It cannot be division. We just need to understand that dividing by a value is the same as multiplying by the reciprocal. So a common ratio is the value multiplied each time. And in this particular case, I gave you two examples, +3 and 1/5. The formula for a geometric sequence is not exactly like the formula for an arithmetic sequence, but it follows the same principle. A is going to be the zero term of your sequence. Again, your zero term is the term that comes before the first term, and we'll look at some examples of this here shortly. B is going to be that common ratio we just talked about. So the previous slide, I talked about a common ratio of 3 or a common ratio of 1/5. That would be plugged in here for B. X is simply going to be your term number. If you're looking for the 100th term, then you're going to plug in 100. If you're looking for the second term, you're going to plug in 2 for X. So here's an example of a geometric sequence that we're going to spend a little time on. We can see in this sequence that we're going consistently multiplied by 3. Multiplied by 3. Make sure you check that that works for all values in the sequence. I'll often see students say, oh, I know what we did. We added 2. Well, adding 2 works there, but as soon as we get to this next one, we have to say, oh, wait a second, we added 6. If your pattern is not consistent, it's not considered a geometric or arithmetic sequence. So multiplying by 3 here is the answer, and we can see that we end up with 27. We could take that times 3 again, and we get 81. We continue this pattern to infinity. Let's use that equation. The equation we have for a geometric sequence is y equals a times b to the power of x. Remember that a is our common ratio. So the common ratio here is what we're multiplying by. That's going to be 3. And b is our zero term. The zero term here is actually going to be a little bit tricky to find. We have to understand that if we're going this way, we're dividing by 3, dividing by 3. 1 divided by 3 is actually just 1/3. And this is our zero term. So the zero term gets plugged in there for b, and we end up with this equation. Y equals 3. I actually got these backwards. I apologize. Strike one, Mueller. We've got to erase this and this, and we got to cross them. The first one, A, is your zero term. So the zero term goes in right here for A, and your common ratio goes in for B. So in this particular case, we're going to have y equals the zero term is 1/3 times the ratio, which is 3 to the power of x. So this equation right here represents this sequence. If I wanted to find the 100th number in this sequence, so we wanted to go way over here and find the 100th term, I would simply take and plug in 100 for x and simplify. If I did that, if I did plug in 100, you can go ahead and try this at home. If you plug in 100, you're going to end up with something like, I'm going ahead and calculating right now. I don't have it in front of me. So calculating this, you're going to take 1/3. You might have to use the calculator I shared with you, but 1/3 times x to the 100. It's 3 to the 100th power. You end up with a very, very, very large number. You'll probably actually see your calculator go something like 1.7 blah, 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 e to some large value. That's just a scientific notation. Maybe this is a poor example. We probably won't be plugging in terms like 100, but that is what you would do if you needed to solve this problem. I just want to go back and make sure I've got this right. I do. B is your common ratio, and A is your zero term. So again, here's an example of this sequence. Finding the 100th term is probably a poor example because it's going to be such a large exponential value. So don't worry about that part of it. Finding a common ratio. You'll notice that in this particular sequence, the signs are changing from positive to negative to positive to negative. That is a hint that your sequence is going to be multiplied by a negative value. So because the signs switch back and forth, or multiplied by a negative value here, 3 times negative 5 is negative 15, times negative 5 is 75, times negative 5, etc. So it asks for the common ratio. The common ratio of this sequence is going to be negative 5. This sequence is one that I would really stress you take the time to look at and pay close attention to. We are actually multiplying this time by a fraction. So if you look at our first term here, you have to ask yourself, 3 times what is going to end up with 3 over 2? Because 3 over 2 is our second term. So we're just kind of looking at how do we go from our first term to the second term here circled in green. And the answer is simply this. You have to multiply by 1 on top and 2 on the bottom. So that gives you that common ratio of 1 over 2. And we can see that we multiply by 1/2 each time, and we end up with this particular sequence. So continuing to multiply by a half will continue to extend this sequence. Once again, if I wanted to take a look at the formula for this, rather than multiplying by a half, I need to multiply by 2 to go backwards. So this is going to be 6, basically saying that I could continue this pattern. That makes 6 the zeros term. So my equation is going to be y equals 6 times 1/2 to the power of x. Write a rule to describe each sequence, then find the first, fifth, and 12th terms. So we're going to go ahead and do this. I'm going to give you this number sequence. I'm just making up an example here. I'm going to start with negative 8. Then I'm going to go, let's see. We're going to go positive 4. Then we're going to go negative 2. Then we're going to go positive 1. First thing we need to figure out is what's happening here. It looks like I'm dividing by 2. Remember, we have to say we're multiplying by negative 1/2. Again, I know it's negative 1/2 because the signs are changing. So we're multiplying by negative 1/2 each time to continue this sequence. So my equation is going to be y equals the 0 term. Again, would be like going backwards. Think about what number do you have in here so that if you multiply by negative 1/2, you'd end up with negative 8, and the answer to that is 16. Another way to look is you're timesing by negative 2, timesing by negative 2, multiplying by negative 2, multiplying by negative 2 to get that. So my 0 term is 16 times this common ratio of negative 1/2 to the power of x. So in this situation, if you wanted to find, I'm not going to do all of these, if you wanted to find the 12th term of this particular sequence, you're going to go ahead and you're going to plug 12 in right here, and I'll do that now. So we're going to end up with y equals 16 times negative 1/2 to the power of 12. And again, you can use a calculator to calculate this. We're taking 16 times, make sure you put fractions in parentheses, negative 1/2 to the power of 12, and you end up with 1 over 256. So this would be the 12th term of the sequence. Again, if you get that as a decimal, you can use a calculator to convert it to a fraction, but there is an example about how you can find future terms using the formula y equals a times b to the x. Remember that a is your 0 term and that b is your common ratio. State the common ratio of the sequence. So these are just some practice questions you could do at home. I don't need to do all of these. I'll buzz through a few. So in this particular case, it looks like we're dividing by 4. Remember, key point that you can't divide by 4. Dividing by 4 is not allowed. So we have to multiply by 1/4, which is equivalent. Okay? So 1/4 is the common ratio. Do not get baited into that trap right there. Dividing is not allowed. It's actually multiplying by a certain value. State the common ratio of this sequence. This is a little bit trickier because we'd ask ourselves, I don't know what to multiply by 4 to get 10 because you aren't comfortable with 4 times what equals 10. We don't have any values. The thing I would tell you is that 4 times 3 is 12, and 4 times 2 is 8. And hopefully, based on this diagram right here, we can see that the common ratio is going to be what? For this first one, it looks like we're multiplying by 2.5. However, you'll quickly realize that if I take 10 times 2.5, so 10 times 2.5, that would give me something like 25, and that's not going to work. So multiplying by 2.5, that does not work. So the correct answer to this one is kind of a trick question. There is actually no common ratio because a common ratio says that you're multiplying, and we're not multiplying. In this situation, we're actually adding 6 each time. So this would be an arithmetic sequence, and this would be considered a common difference. So be careful with those two. Understand that a common ratio means multiplying. There is no value to multiply by, so we're being tricked. I'm going to skip over just a couple of these quick. I think that's enough to get you going on this lesson. If you have any additional questions, please let me know. I will save these notes as well as this video. Good luck. Happy snow day. This is our first shot at an e-learning day, so hopefully it goes as planned. See you later.